Howdy students, this is Unit 16, Part 2. We're going to cover Part A in this video, and then we will work on Part B in the second. This video is going to contain information about how to use redox equations to label which chemical species is oxidized and which one is reduced. So an oxidation, by definition, is when we lose electrons, but when we look at specific reactions, it's going to be an increase in oxidation number. So our last video that we made, 16.1b, is going to be something you'll need to know in order to find these. Reduction is a decrease in oxidation number. And again, we covered that in video 16.1b. Oxidizing agents are the substances in a redox reaction that accept electrons, the substance that was reduced. Whereas only an element can be reduced, the entire reactant is called the oxidizing agent. The reducing agent is the substance in a redox reaction that donates electrons, the substance that was oxidized. Whereas only an element can be oxidized, the entire reactant is called the reducing agent. So what do we need to take away from this slide? When we are labeling agents, these are going to be the entire chemical compound. Now, when we are labeling what is oxidized and what is reduced, these will be single elements. Okay, so we're going to go over some redox reaction examples. We're going to identify the element that is oxidized, the element that's reduced, the oxidizing agent, and the reducing agent. So there's 4 parts to each of these types of questions. So here's our first example. What we're going to have to do is go through and we're going to have to label each oxidation number, which again we covered in the last video. So if you need to refresh on that, we have rules that allows us to identify and solve for different oxidation numbers. So that's the first step. I would go through and I would actually label each element's oxidation number. A couple things to point out from the last video. Free elements have an oxidation of 0. Group 1 elements like hydrogen have +1. Oxygen is always 2-, unless it's a free element. And we'll have to solve for transition metals, in this case, manganese. So before I move on, let's talk, what is the elements that stay the same aren't going to be a part of how we label these oxidizing agents and reducing agents. So we want to know from the left side of the equation to the right what has changed. Which oxidation numbers have changed? And that's when we identified the manganese. It went from a +4 to a +2. Its oxidation has gained 2 negative electrons. Now, the number went down, but the reason it went down was because we added 2 negative electrons. And when we gain electrons in redox, that is a reduction. Oil rig, reduction is gain of electrons. So manganese has been reduced. What else has changed? Looks like the chlorine went from a -1 to a 0. It lost 1 electron, and when we lose 1 electron, we become more positive. And so, oxidation is loss, oil rig, chlorine has been oxidized. So then we have to label our agents. If it was reduced, then the reactant that contains manganese is called the oxidizing agent. So this whole entire compound is the oxidizing agent. If it was oxidized, then the reactant that contains chlorine would be considered the reducing agent. So this is kind of confusing for some students. It's just a wording issue. Chlorine was oxidized, which means the whole compound, the entire compound, is the reducing agent. Okay, so we're just going to work through some examples for this video, and then we will be done. So here we go. Let's label our oxidation numbers. Copper's by itself, it's a free element, it's 0. We solve for N here. So we would have had to solve for N. Now in this one, we would have provided you with copper's oxidation state, and then you would have had to solve for nitrogen. Nitrogen dioxide, we have a -2. We would have solved again for nitrogen here, and then H2O +1 -2. So from the left side to the right side, copper has gone from a 0 to a +2. And to do that, to go up in a positive number, we have to lose 2 negative electrons, which has been oxidized. Nitrogen went from a +5 to a +4, which means we had to gain 1 electron there, which is reduced. Now, the entire compound that contained that copper is the reducing agent, which in this case is also Cu. Because it's an element, it's also the entire compound. Now, the nitrogen was a part of nitric acid, HNO3, which means the whole entire thing is the oxidizing agent. Okay, so here we go. Let's practice. Write the oxidation numbers of the elements and then indicate which substance was oxidized, which was reduced, and the agents. And then we'll stop for this video. Magnesium is 0. It's by itself. Oxygen is also 0. Group 2 elements, like magnesium, is a +2, while oxygen is a 2-. So manganese went from 0 to +2. To do that, it had to lose electrons, 2 of them. So magnesium has been oxidized, which means the reducing agent is magnesium. Oxygen goes from a 0 to a 2-. It picked up. So the element oxygen has been reduced, which means O2, the whole compound, is the oxidizing agent. Next example. Silver, we're going to give you as +1. We'll provide that for you. Oxygen's 2-, so I'm going to need to solve for my nitrogen. So silver is a +1 plus X plus 3 times 2- equals the overall charge. So in this case, we'll have X plus 1 minus 6 equals 0. X minus 5 equals 0, so nitrogen is a +5 here. Copper is 0, it's by itself. We'll have to be given copper in this one. In this one, it's going to be a +1 charge. And we'll have to solve for nitrogen once again. +1 plus X minus 6 equals 0. So again, nitrogen is a +5 here. Silver is a 0, it's by itself. So silver goes from a +1 to a 0. It has gained an electron, which means silver has been reduced, which means the oxidizing agent is AgNO3. Copper has gone from a 0 to a +1. It has lost an electron, so copper is oxidized, which means copper is the reducing agent. And then our last example for this video, CH4, hydrogen's +1. So in this case, carbon actually has to be a -4. Oxygen 0 here. 2 minus, carbon is a 2 plus, plus 1, and a 2 minus there. So carbon has gone from a -4 to a +2, which means it has increased in number, and to do that, it had to lose a bunch of electrons. And so carbon has been oxidized, which means the reducing agent is CH4. Oxygen went from a 0, and then in both cases went to a 2 minus. So it has gained 2 electrons, which means oxygen has been reduced, and the whole compound would be the oxidizing agent. 2 minus, carbon by itself, iron by itself, 2 minus here. We're going to have to solve for iron. 2 times x plus 3 times -2 equals 0. So 2x minus 6 equals 0. 2x equals 6. X is going to be equal to 3. So iron is a 3 plus. And then carbon is going to be a +4. So oxygen has stayed the same. Iron went from a 3 plus to a 0, so it has gained 3 electrons. So iron is reduced, which means Fe2O3 is the oxidizing agent. But what you'll also notice is that carbon goes from a 0 to a +4. We have lost. So carbon has been oxidized. Carbon is the reducing agent.